Our next functional group is alcohols. Do apologise about the low light on this. We've had a little bit of a problem with our lights in this classroom. Alcohols are the ones with the functional group OH, or a hydroxy group at the end of them. So normally the way that we write it is R to show any carbon chain. So it can be as short as having just one carbon on it, and then OH. Alright? And we've got a good example of one here, C4H9OH. And if we have a look at a mathematical arrangement, or a mathematical formula sort of to remember this, remembering that our hydrocarbons were things like CnH2n plus 2, CnH2n, CnH2n minus 2 for your alkynes, that sort of thing. If we have a look at this, it's going to follow the same sort of pattern. CnH2n plus 1. The reason is that it's basically an alkane with one of the hydrogens replaced by OH. So it's the alkane one, and rather than plus 2, it's just plus 1. So CnH2n plus 1, and then OH. Now the reason that we don't just call it CnH2n plus 2O, so C4H10O, is that that molecular formula can be another thing called an ether. So it could be this sort of thing here, where it's CH3, then an O, then CH2, CH2, CH3. This is the same molecular formula, but it's a different general formula. So that's why it's specifically laid out this way here. CnH2n plus 1, and then the OH. So you see the H is mentioned twice. It shows the functional group that gives all the typical properties. Right, just quickly going to go through a couple of those typical properties with you. If we have a look at the most obvious version of this here, which has got 4 carbons, so it's a type of butanol, then we can see that on the end it has an OH group. And anything with an OH group at the end is able to make what we call hydrogen bonds. Alright? It's technically not really a polar molecule because the carbon chain is so long. So the main type of bonding there would be temporary dipole forces. So it wouldn't dissolve very well in water at all. But it dissolves better than we think because of this OH. It's able to make hydrogen bonds with the water molecules around this end. So it can dissolve just a little bit. As well as that, because of this group here, it can have a relationship, again with a thing called a hydrogen bond, with the OH group of a neighbouring molecule. And that means that the melting and boiling points are considerably higher than those of alkanes and alkenes. So you'll find that where, say, a 2-carbon alkane and alkene would be gases, a 2-carbon alcohol, ethanol, we know pretty well now, is a liquid. Okay, so its boiling point is considerably higher than that of ethene and ethane, which are both gases. And it's because of this strong bonding between the OH groups of these alcohol molecules. Right, the last thing I want to go through very quickly is the isomerism that these can exist with, and how we name them, because their naming can get a bit tricky as soon as you get to about 3 or 4 carbons. So we're going to make a few versions of this and try to name them. So our first one is the one we've got here. We've got CH3 down to CH2, CH2. And I'm going to show this with the alcohol carbon expanded out a bit more. Because it's an alcohol, it ends with the suffix -ol. Alright, so these are alcohols, so you end the name in -ol, O-L. Then we need to number the carbons. And remember in previous things we numbered them both ways, because we're trying to find the lowest number that the functional group is on, the thing that gives it its properties. And we can see that it could either be carbon 4 or carbon 1 where the OH is bound. Well, 1 is lower. So what I'm going to do for my naming is I'm going to put the 1 there now. I could put the 1 at the very start of the name of the compound if I'd like to as well. So I'll give you the other name in a moment. Then, because it's got 4 carbons, so I should really count this way, away from the OH, 1, 2, 3, 4, and they're all in a chain, so it's straight chain, not branched, then it's butane-1-ol. The reason we put the AN in there, butane, not just but-1-ol, butane-1-ol, is you can have things with double bonds in them as well, so that'd be like called butene-ol. So the AN means that these are all single bonds between the carbons. Because if one was a double, you'd call it butene-ol instead. The other name for this one, which is equally correct, is just 1-butanol. Both would be accepted in the assessments. We call this a primary alcohol. That's its classification. So if you're ever asked to classify alcohols, this means calling them primary, secondary or tertiary. As I go through some more structural isomers of butanol, I'll show you what that means. This is called a primary alcohol because the carbon that I've circled is only bound to one other carbon. So it's what we call a primary alcohol. The reason this is important, we're going to learn about in our next lesson when we learn about the reactions of alcohols. You're going to look at the difference between primary alcohols, secondary alcohols and tertiary alcohols and how they react with things like dichromate and permanganate and things like that. Right, so now I've got this nice 4-carbon chain. I'm going to move the OH off there and I'm going to put it onto carbon number 2. So I'm just going to take that off there, put it there. It's going to have to displace a hydrogen, so I'll put that hydrogen on here. So what's that going to look like?
Why do you put it onto that sheet?
I'm just trying to make a different structural isomer of it. Okay? So, again, I'm going to number this longest carbon chain is here. I'm going to number that both ways to try to find the lowest number that I can put the OH on. And I see that it's on 2 or 3. So, can anyone guess what its name might be? One of its names. It's got 2 correct names. Butane-2-ol or
2-butanol.
Great. So let's put those 2 down. Righto. Now, if I look at the carbon that I've circled, the one with the OH on it, how many carbons is it bound to? 2. Okay. So if this one here was called a primary alcohol because it was only bound to 1, guess what classification of alcohol this is?
Secondary.
Secondary. Brilliant. So can anyone guess what a tertiary alcohol would look like?
The 3 carbons.
Good. So I'd actually move the CH3 group from here up onto here. So let's see what that looks like and how we name it. Because it's one that you see every few years in assessments. They get you to name this one. So I'm going to shorten my carbon chain to only being 3 carbons long. Still with my OH group in the middle. But now I've moved that up to the top. So it looks like this. No matter which way I look at this, the largest carbon chain is going to be 3. And no matter which way I number it, the middle carbon is going to be number 2. So, the first thing I need to see is that it's not called a butanol anymore. What would it be called? Good, it's a propanol, okay? So, it's got to be a 2-propanol as well, because I can move the OH and it would be different, okay? So, it's still going to be something propan 2-ol. Hopefully that fits on the screen of the camera.
Yep.
It's also got a methyl group coming off the side. Okay, so here's our propanol, our 2-propanol without that here. But it's got this methyl group coming off the top. If that methyl group was here, it would give us a 4-carbon chain, so you don't need to number it. There's nowhere else you can put a methyl group. So we just call it methyl or methyl propane 2-ol, or methyl 2-propanol. Those are equally correct. If you're unsure, number your methyl group as well. Okay, if you're not sure, number it. Alright, but technically speaking, this one shouldn't be named because if I moved it, I make a 4-carbon chain, so I make one of my butanols again. Okay. This one has got, as you said correctly, 1, 2, 3 carbons coming off the one that I've circled, so it's called a tertiary alcohol. There is one isomer I haven't put in here. Can anyone work out what it might be? Right. Could have a cyclic, not with that formula, but I could have a cyclic alcohol, that is correct. I'll give you a wee bit of a hint. It's a derivative of the very first one that I drew. It's kind of a cross between the first and the last one. Not quite. You don't have double bonds, so you won't have cis trans. If I take this CH3 off and I put it here, does that make something different to those two? Just the methyl group, and put it onto carbon number 2. Does that make something different to what I've got up there? Cool, so it'll make methyl propane 1-ol, which is different to all of those again. Okay, which would be, I'll draw it because I want you to tell me if it's primary, secondary or tertiary. So this one here is, here's our 1, 2, 3 carbons for my biggest chain. It's an OH, it's on number 1, so it's something or other propane 1-ol. It's got a methyl group there, so it's methyl propane 1-ol. Primary, secondary or tertiary?
Primary.
Okay, we're looking at this carbon here. You see I've always got the same little routine that I do. I circle along the OH. How many carbons is that one directly bound to?
1.
Just 1, so is it primary? Yes it is, well done. Okay, unlike these ones where when I circled it I could draw 2 or 3 little green lines. Here I'd only have 1 little green line to show that. Alright. That's a little bit of an overview about alcohols. We're going to do their reactions and other properties in more depth in our next lesson.